So yesterday we were discussing on change of scale and origin, right? Today we'll continue with some numerical problems on the same content. It's called as change of scale, or things will be having this called as and or origin. Okay. Before I continue, let us discuss as three cases. Case one, and case, which means change of scale, change of scale, and change of origin both. Okay. Next case, case two, change of scale or of change of origin. Okay, so this is and, this is or. What do you mean by and? Both. Or means either change of scale or change of origin. Okay. Third case, actually we'll be dealing this way. We'll be dealing this way. Case three, change of scale and or, which means what? Both. Change of scale and or, which means both. Change of origin. Okay. First, let us discuss this with measures of averages. Measures of averages. So, measure of averages first. Then we'll go for measures of dispersion. Can you refer the properties and tell me which one will be satisfied and which will not be? Yes, please. Go for page number 2.7. Can you find the 2.7 page? Where 2.6 of 2.7? See this property. 2.7 property number. Actually, this property number is 4. Arithmetic mean is affected due to change of scale and or change of origin and or scale. I request you to go through this property in page 2.7 and under the measures of dispersion, you can find another property over here. Property 2, affected due to change of scale but by absolute values, which means we are not going to give importance for the sign. If there is a negative sign, we will eliminate it, but of origin. Okay. Can you just go through, please? Yes, with respect to measures of averages. Yes, please join. What happens? Change of scale and change of origin. Does it get affected? Please refer the property page 2.7. How the line starts. Aims affected by change of scale and or origin. Am I right? So there is a change of scale and there is a change of origin. It gets affected? Yes. There's a change of scale or change of origin. Yes. It gets affected. AM will get changed. And both. Actually, this is following from both the two cases. Follows from case 1 and 2. Okay. Case 1 and 2. It's not a separate case. Okay. So tick. What about measures of dispersion? Change of origin does not affect, right? Change of scale affects, but by absolute value. Here I have a and one, which means what? Only origin will not get affected, which means origin will not affect, scale will affect. Because I'm using and, I cannot have a tick mark. At the same time, it affects when the scale is changed. So I cannot have a into mark also both. So I'll put a star and you have to decide accordingly whether it's tick or not a tick. When you go for change of scale or change of origin, yes, or only, right? So you get a tick. And this one, because it's a tick and an into, the same thing follows here also. You can. So you can please make a note of it because you will get a question like change of scale and a change of origin or change of origin. You have to decide accordingly. But please note for change of a measure of dispersion with respect to change of scale, yes, it gets affected, but by absolute values. You have to make a note of this. But by absolute values. Yes, please. Yes, please. Let us go for some numerical problems here. I'm planning to discuss some four problems where you're going to do. Let me go like this. I have given a set of values, x values, and I'm going to do some change of scale and origin concept. Because of that, I'm going to get y. Okay, what will be y bar value? What will be median of y value? What will be mode of y value? What will be range of y? What will be mean deviation of y? What will be standard deviation of y? And what would be variance of y? We are going to discuss all these cases. So how many cases have we have put together? These falls under averages. Okay. So 1, 2 and 3. These 4 falls under measures of dispersion. So I'll have this as 4, 5, 6 and 7. Continuation of numbering. So first case, I have a x and this x, what I'm doing here is I'm adding a 2 so that I get a y. So how I get this y? X plus 2. To each and every x I'm adding 2. This concept is covered under change of scale or change of origin. Change of origin, because change of origin is involved with addition or subtraction. So this is change of origin. Okay. Now tell me, what happens for y bar? Y bar value? X bar plus 2. Okay. So this y bar will be x bar plus 2. See, the concept is simple, bar. We have discussed in a detailed way yesterday, okay, last class. Here, whenever we have x and you're going to find y, if it is x bar, you'll get y bar. How? In case y is equal to x plus 2, it gets affected means because of changing each and every value of x, y bar also gets changed. How much? X bar plus 2. So wherever you get x, you're going to substitute. This is with respect to change of origin concept. So this is a y bar is equal to x plus 2. Median. Median of, yeah, please, median of y is equal to median of x plus 2. Okay, not getting enough space. Okay, no issues. Yeah, next one, mode. Mode of y is equal to mode of x plus 2. Is it okay? Can you just follow for others? Can you tell me for others? Range of y is equal to. Please check whether your answering is right. Please check whether what you are telling is right. Right. Go for page 2.11. Measures of dispersion. It's 2.11, right? What happens? Read the line. Yes, anybody can read the line for me. Affected by due to change of scale, but by absolute values, but no origin. If you are shifting the origin, range will not get changed. Okay, see what happens? Zero. What happens? Zero, zero. Changes because of scale, but by absolute value. See, multiplied by modulus of b value. Multiplied by modulus of b, which means negative sign is removed. Okay, for variance, you have to square it. Okay, now come back. Join here. Tell me. Yeah, please make it faster. Range of y is equal to range of x alone. 2 will not have an impact because 2 is related to change of origin. It will not impact range of y. Now tell me, mean deviation of y will be equal to mean deviation of x alone, which means it can have 0, which means there is no affected value. Standard deviation of y is equal to standard deviation of x plus 0. Variance of y is equal to variance of x. No, variance of x. The constant which you are multiplying alone will get squared at. Variance square வரும். ஆனா வந்து constant 1 தானே இங்க. 1x தானே. So 1 square 1 1. Standard deviation. See, okay, go this way. What is standard deviation of y? If it is y is equal to ax plus b, what will be y bar? Ax bar plus b. What will be standard deviation of y? A into standard deviation of x plus 0. Because change of origin has no impact. And this is not a, instead this is a bar. Sorry, what absolute value of b. What's the relationship? What's the relationship between standard deviation and variance? If this is sigma, you square the value, you get variance. Which means you want to find for this, you square this value. What will happen here? A will become a square square. Is it okay? So standard deviation will have absolute value b or a, whatever it is in this. And for variance, we'll get the square of the values. Okay, shall I take over? So here, first one is done. Shall I go for the second example? I'll do it or you'll try. Second, y is equal to minus 2x. I'll do it or you'll try. Okay, please try that. Yes, ma. Y bar. Y bar. Arithmetic mean gets affected both by change of origin and scale. So y bar is minus 2 into x bar. Okay. See, whatever you have, instead of x, substitute x bar. This is happening for arithmetic mean, median and mode. Only for measure of dispersion you should be careful. Okay. Yes. Median of y. It's equal to minus 2 into median of x. Mode of y. Which is equal to minus 2 into mode of x. Is it okay? Till here is fine, right? Shall I continue? Range of y. Range of y will be, yes, please join. Check. Yes, it is modulus of minus 2 into range of x. So this is 2 times of, yes, next, mean deviation of y to mean deviation of x. Standard deviation of y, 2 into standard deviation of x. Yes, variance of y, 2 to 4. 4, variance of x. Is it okay? For variance, we square it. Okay? If this is okay, then third, you can try for y is equal to minus 2x plus 2. Fourth case, y is equal to minus 2x minus 2. Fifth case, I'll tell a bit later. So what is happening in the second case is, actually there is a change of scale. You agree with me? Please join with me here. What is happening in second case? Change of scale. By how many units? Minus 2. Okay. Third content, there's a change of scale and also there's a change of origin. Okay, both origin and scale. And here also origin and scale. Okay. Fifth one I will discuss later. Yes, please join. Finish it off, make it faster. Yes, what happened here? Y bar is minus 2x bar plus 2. Let me work out simultaneously for the other case also, okay? So here y bar will be minus 2x bar minus 2. It's quite simple. Median of y will be minus 2 median of x plus 2, and here median of y is minus 2 median of x minus 2. Here, mode of y minus 2, mode of x plus 2. Here, mode of y, mode of x minus 2. Okay. Ry is equal to Rx. That's it. No plus 2. See, change of origin is not affecting. Okay. Yes, this one. R, Y. Yes, please. Minus sign is also not affecting. Yeah. Mean deviation of Y. Will get plus 2? No. Mean deviation of Y. Yes, please, John. 2. Mean deviation of X. Will get minus. Will get minus over there? No. Okay. Next. Standard deviation of y is equal to 2 into standard deviation of x. Standard deviation of y is equal to 2 into standard deviation of x. The last case, quite important. Variance of y is equal to 4 into variance of x. And here, variance of y is equal to 4 into variance of x. Hope it is clear. Now, fifth case. I'll discuss this fifth case. If it is given y is equal to 3x plus 2 by 5. Okay, what has happened? Please check. There is x. Okay. To this x, you multiply by 3 so that you get 3x. To this 3x, you add 2 so that you get 3x plus 2. To this 3x plus 2, you divide by 5 so that you get 3x plus 2 divided by 5. So, what are the things are happening here? First is change of scale. Okay. Next is change of origin. And again, there is a change of scale. Multiplication and division means change of scale. But instead of doing step by step like this, what I can do over here is, please check whether I can write this one as 3 by 5x plus 2 by 5. Yes. Yes, I can write it. That's the beauty of maths. You need not go as a three-step working. Directly, you can make some simplifications and you can directly take it as 3 by 5x plus 2 by 5. Yes, tell me, Pa. What is y bar? Yes, please join. 3 by 5 x bar plus 2 by 5. Yeah. Median of y. 3 by 5 median of x plus 2 by 5. Yeah. Mode of y plus 2 by 5. Yeah. Range of y. Good. Next. Median of y. Mean deviation of x. Standard deviation of y. Variance of y. அப்படியே மல்டிபிளிகேஷன் டேபிள் மாதிரி வரணும். 2 2s are 4. நைட்ல எழுப்பி கேட்டாலும் சொல்லணும். ஓகே எஸ். Change of scale and origin over. Let me go for continuing with yes, please. First one. For the observations, assumed a variable of constant and measure of dispersion is 0. If all the observations assumed by a variable of constant, the measure of average is. If all the observations assumed by a variable are constant, then the measure of average is the same number. See, for example, if we take 2, 2 and 2, we take arithmetic mean 2, median 2, okay, mode 2. But what happens? There is no deviation at all. All the numbers are same. See, we started the concept like this. You remember? We have all the values dispersed and it's all tending to one single value, and that value is what you call as the center tendency average. Okay. Likewise, and I have another set of values, and that is also tending to some point average. Okay. And this average same happens to be the same value. Here it is 2, 3 and 5. What is x bar? So 2, 3 and 4. What is x bar? 3. 1, 3 and 5. X bar 3. In both the cases 3. Which one you are going to say is better? So we'll go for checking the dispersion, deviation. So deviation is something how far the values are getting deviated. All the values are 2. Which means there's no deviation at all. Which means if all the observations are seen by a variable of constant, the measure of dispersion will be 0. So range will be 0. Usually we are not going to discuss quartile deviation because quartile deviation in each and every case is giving an alternate result. So we are not discussing quartile deviation and it's not in our scope of syllabus. So range will be 0, mean deviation will be 0 and standard deviation also will be 0. Property 2, yes, we have discussed. Affected due to change of scale, but not by origin. Scale also not directly with the negative values, but only by absolute values. So if I have y is equal to a plus bx, actually this I have missed out. You can please make a note of it. If I have the equation like y is equal to a plus bx, then ry will be, a will become 0. Why? Because a is independently standing, change of origin. So 0 plus modulus of b into rx. Is it okay? Likewise, standard deviation of y will be same and sigma y will be same. This is with respect to variance, not by origin but by scale but square of the value. Is it okay? Property 3, we have already discussed. This follows from median property. Follows from median property. Can you refer the property in the previous page? What's the median property? What's the median property? See, property 2, what does it say? For a set of observations, the sum of absolute deviation is minimum when the deviations are taken from median. Absolute deviation means I have to take the modulus height. Deviation is minimum when the deviation is taken from where? Median. So x minus median. Okay. And this is happening with some of the absolute deviations. So if you take this way, this will be minimum. And now my property here with respect to mean deviation takes as minimum value. See, what is the mean deviation formula? Summation, the modulus, summation modulus of x minus a divided by n. A can be the mean value or a can be the median value or a can be the mode value. Okay. But what the property under the median says, it will be minimum only when taken from median. So if I apply this one over here, this a, when I take it as median, obviously this mean deviation is going to be the minimum value. Okay. See, usually I write median as this way, M and D, but in most of the books it is written as M and E because for X bar we are using for mean, right? See, mean is having the same spelling starting with ME. Median also same spelling starting with ME. So what usually I do is I use MD for median. Okay. There are many books many authors where they use MD for median and some authors they use ME for median. Okay, but whatever it is, the abbreviation for this will be given in the okay. So the question paper. So here mean deviation, ME is written means we'll take it as median. Okay. So this is property 3. Is it okay? Shall I take over? Next is property 4. This is with respect to combined standard deviation. So you can please join with me. Combined standard deviation. Okay. Already we have done this related concept called as combined arithmetic mean. You remember? The group 2, which is having N2 as a size. X1 bar is the first group mean. X2 bar is the second group mean. We can find X1 2 bar in the formula. N1 X1 bar plus N2 X2 bar. N1 plus N2. Okay. Likewise, we can find combined standard deviation with the formula. Representation is S12. 1 2 is representing first group and second group clubbed together. So S12 is equal to root of N1 S1 square plus N2 S2 square plus N1 D1 square plus N2 D2 square divided by N1 plus N2. What is this D1 and D2 is? D1 is a deviation taken from the combined mean for first group mean. D2 is the deviation taken from combined mean for second group mean. Okay. So if you know all these values, which means N1, N2, X1 bar, X2 bar, then you can find X12 bar, right? With the help of this formula. After this, you can find D1. After this, you can find D2. Okay. And if also S1 value is given, S2 value is given, yes, you can substitute and you can find the value of S1. Okay. Now what happens is we are going to discuss two cases over here. Shall I continue, Papa? First case, if X1 bar and X2 bar happens to be the same value, what will happen? Can you turn over to mean properties under combined arithmetic mean? Can you please turn over? I think page number 2.7 or 2.8. See this one. Under 2.8, this property, combined arithmetic mean. If the averages are same, which means X1 bar and X2 bar are same, then the combined mean is nothing but the average itself, which means X1 bar, X2 bar, and X12 bar will be same. Okay, so this is about my first discussion. If X1 bar and X2 bar are same, means this will be nothing but X12 bar itself. Okay, now what will happen for D1? What is D1? X1 bar minus X12 bar. Both the values are same, so we become 0. Likewise, what will happen for D2? X1 bar, sorry, X2 bar minus X12 bar. Same value, so 0. So now this formula will look like S12 is equal to root of, yeah, please, N1 S1 square plus N2 S2 square plus 0 plus 0. Because D1 and D2 are 0. Divided by N1 plus N2. So this is, if I take variance, this is square, that is removing square root. What will happen here is N1 S1 square plus N2 S2 square divided by N1 plus N2. This follows the formula called as summation Wx by summation W, the weighted arithmetic mean formula. Okay, so you can please have a note over here. This is nothing but, is not there in the material. I have to include that. This is variance of two groups, 1 and 2, will be equal to weighted, not arithmetic mean. This is arithmetic mean formula. Instead of x, I'm using standard deviation square. So weighted variance of group data. Weighted arithmetic mean only. Sorry, weighted arithmetic mean of what variance of two groups. Yes, please make a note of it. This is case one. Should I take over? Case 2. In case the sizes of the two groups are same, which means N1 is equal to N2. So for convenience sake, we take it as N itself. What will happen? Please join. S12 is equal to root of n s1 square because n1 is same as n. Likewise, n s2 square plus n d1 square plus n d2 square, the whole divided by n1 plus n2. Now this n happens to be a common one. So let me take n throughout common. So this will be n into s1 square plus s2 square plus d1 square plus d2 square divided by 2n because n plus n. I strike out. So this will be root of, shall I write this way? Please check. S1 square plus S2 square divided by 2 plus D1 square plus D2 square divided by 2. Now, if I go for taking away the square root, so this will be S12 square, which is variance of the two groups, will be equal to, removing the square root, this is the arithmetic mean of, yeah, please, arithmetic mean of what variances plus arithmetic mean of deviations. Am I right? What do you mean by arithmetic mean? Add and divide. So arithmetic mean of variance of two groups. Add two groups variance and divide by two. Arithmetic mean of the deviations. And actually arithmetic mean of the square of the deviations. Square of the deviations. Zero. Arithmetic mean of variance of two groups. And this is arithmetic mean of square of the deviation. Yes, ma'am. Can please make a note of it. Like to take over. So this is the formula, right? In case the two groups detail are given, but one figure is missing. For example, N1 is 5, N2 is 15, which means what? Size of group 1 is 5 items are contained in that, and in the other group, 15 items are contained. Okay. And I have X1 bar, which is 9, X2 bar, which is 5. S1 is also given, which is 0.8, S2 is missed out. We have to find the missing data. Along with this, S12 is given. S12 is given to be 1.83. We have to find S2. How can you do it? Just substitute all the values, cross multiply, and you can find it. So you can take this as an assignment. Actually, this problem is there in the material, where in single material you will be finding the other way, which means you will be finding the combined standard deviation. Okay. See, this problem only I gave you. See, 5, 15, 9, 5, 0.8. This is 1.83. We have to find this value, which means substitute all in the formula. Check whether we are getting 0.5. Okay, so you can try this. Shall we go for the next content? There's one small content pending. Want to make a note of it. So this is the problem. You have to check whether you're getting 0.5. This is the problem. Okay, yes, please. Let's take over. Next concept is on coefficient of variation. In short, we write it as C dot V. Coefficient of variation is used for comparison of the data. Okay. When we talk about measures of dispersion, we'll discuss in two ways. One is absolute measure and one is the relative measure. The best one under the relative measure is coefficient of variation. Okay. Let us take two groups of values given, 1 and 2. What's the formula for coefficient of variation? You remember? Sigma by x bar into 100. So, our two groups given. First group's arithmetic mean is 9 and second group's arithmetic mean is 5. It's there in your material, you need not take a note of it, just listen. And we have the sigma value, sigma, or you can write it as S. Okay. So this is S1 is equal to 0.8 given and S2 0.5 given. Okay. Let us check coefficient of variation of this first group. Okay, tell me. First group variations. There is coefficient of variation. S by x bar into 100. Yeah, value. Yeah, value 0.8 divided by 9 into 100. Value. Give it for two decimals. 8.89. 8.89%. Over here, coefficient of variation for group 2. S value. S by, actually this is S1 by x1 bar. This is S2 by x2 bar into 100. Yeah, value. 0.5 divided by 5 into 100. You'll get exactly 10%, right? Now tell me. We are going to compare, right? These two values. Which value is lesser and which value is greater? We get this type of relation. So when a question is asked with respect to stability, which is more stable and which is less stable. This is less, sorry, this is more stable. Stable means how closely it is packed. Okay, this is more stable, this is less stable. Because when you say the deviation is 10% means it is a bit far away. The values have been far away located. When you say it's 8.89%, see, without comparing, you cannot say, compared to this 8.10%, 8.89% is somewhat closely packed. So we call this data as more stable. Okay, with respect to stability. Second one, with respect to consistency, how far it is consistent, which is more consistent? This is more consistent. This set is less consistent. Okay. Third one, how far it is variable, variability. This is less variable. This is more variable. Variable means more dispersed. Or you can say how far it is dispersed. Dispersed, or you can use the term deviated. Okay. This is less dispersed. This is more dispersed. One more term, which is scattered. Yes, which is scattered. 10% is more scattered. So this is less scattered. This is more scattered. So you can get any of the terms one. So how your question will be asked is there are two groups with the coefficient of variation this value with the coefficient of variation this value. You will be asked to find which is more consistent. Which means what? The value is less number. That is here. This is more consistent, right? Which means what? The value with less number is more consistent. They'll be asking you which is more scattered. More scattered means more scattered. Okay, that is spread over is high. Then here 10% is compared to 8.89, 10% is more. So this is more scattered. So we'll give the answer as group 2. Is it okay? Yes, that's about measure of dispersion. Done.